For question 1, the group of 6 boys and a group of 5 girls are to be photographed together. The girls will sit on 5 chairs placed in a row, and the boys will stand in a line behind them. Find the number of different arrangements for the photo taking. So let's say, imagine that the camera is here, right? So the girls are just in front, the boys are just at the back. The number of ways you can arrange the girls, right, in row 1, the number of ways you can arrange the girls is just 5 factorial ways, which I can arrange the boys, right? So because there are 6 boys, in row 2, there are a total of 6 factorial ways, right? 6 factorial ways to arrange the boys, and 5 factorial ways to arrange the 5 girls, right? So what's the total answer? The total answer will just be 6 for part 1, will just be 6 factorial multiplied by 5 factorial ways to give the total answer to be 86400 ways, right? Because I just arranged the boys and the girls separately without any difficulty. Okay, so for part 2, for second photograph, the boys are to be arranged with 3 boys and 3 girls standing in front. So I have to have 3 boys and 3 girls standing, or 3 boys and 2 girls occupy the chairs in front of me. So there's 3 boys and 3 girls standing at the back. So this is one possibility. Maybe let me just write it this way. Boy at the back, girl at the back. On top of that, I need to have 3 boys at the front and 2 girls at the front, right? This is how the question looks. They want 3 girls and 3 boys to be standing. They want 3 boys and 2 girls to be seated on the chairs in front, because there are 5 chairs in front, 6 people standing at the back now. So in this row, right, the boys and girls are to occupy alternate places. If I were to look at this, okay, so for the front row, this seems to be the only arrangement, right? Okay, because I only have 2 girls, I cannot put a girl first. It has to be the boy first, because there are 3 boys and 2 girls. So odd number. So this is the only way I can arrange. Only one way I can arrange. And if I think about it, how do I select the boys to be at the front? So now let me look at the boys at the front first. So the boys, you can see that for these boys, I'm going to choose 3 boys, right? So it's like I have 6 boys, I'm going to choose 3. Above that, I also have 3 factorial ways of rearranging them. So it's a total of 3 factorial. So you can see it this way, or you can just say that it's the same as me saying there's 6 ways of going to the first boy, of choosing the first boy, 5 ways of choosing the second boy, 4 ways of slotting the first boy. So the answer is the same, right? Also, for the first girl, right? For the first girl, there are a total of how many ways? 5 girls. I'm going to choose 2, and I multiply by 2 factorial ways, correct? So 2 ways to 5 choose 2, or 5 permit 2 to choose the arrange the first 2 girls at the front, right? And now, after I've chosen the 3 girls, the 2 girls and the 3 boys, what is remaining will be those at the back. Alright, so for the people at the back, we don't have to choose again. But we do take note that now with these people at the back, what's going to happen to them? Right, so if we observe these 3 boys, how are they going to be arranged? Right, there's possible going to be 3 factorial ways. How about these 3 girls? Arrange again another 3 factorial ways. Alright, not only that, is it the only arrangement? Possibly not, right? Because it can also be this way. Right, so for the back row, it can also be girl, and boy. Means we start with the girls on the outside, boys start with the girl instead of starting with the boy. So this itself, right, can account for 2 ways. Right, so if you observe all the things that I've been writing, right, the total answer will actually be 6 choose 3 times 3 factorial times 5 choose 2 times 2 factorial. This is for the front row, right? I'm going to select arrange 3 people from 3 boys from 6 boys at the front. Arrange 2 girls from 5 girls at the front, and at the back there are two ways of me to arrange them. I could start with the boys first or the girls first, multiply by 3 factorial, multiply by 3 factorial. The ways of arranging the boys at the back, arranging the girls at the back, and I could start with the boy first or the girl first. And this total answer is quite a big one. It's actually 172,800 ways. Okay.